So last time we you guys had an asynchronous day assignment. I give you a little video to watch and a delta math to work on. How'd that go? It's okay. Questions from any of that? No. Okay. My plan for today then is, stop talking please, is we're going to work on this 7 through 14 from the homeworks. So these are the same kind of, simplifying the trig identity or trig expression problems like you would have done in the delta math. They're just a little bit more complicated, like it's a layer deeper. So in addition to problems where you'd have an identity to use, here we're also going to have algebra things you might be able to do. So when I say algebra, I mean things like combining like terms or reducing a fraction, making a common denominator, factoring, foiling, stuff like that, right? When I say algebra things. All right, so I'm going to use my random name generator here, and we're just going to call on students. We'll do this kind of together. I'll ask you for the next step as to what to do. If you're not sure, I can throw some hints your way or whatever, talk about what to look at or what you need to do to figure out what to do. And maybe lay some breadcrumbs for you, but that's going to be the gist of what we're doing here. Sound good? All right. First random name is Aiden. So we're looking at number 7. It says cotangent u times sine u. So the first thing you want to do is decide whether you're looking for an algebra thing to do or an identity to do. So Aiden, what do we think? An algebra thing or identity? Identity. I agree. So that's 50% of the way. What identity would we want to use here? Number 6. Odd even identity. Okay, so I wouldn't want to use any odd evens. So my cue for an odd even is that the stuff inside needs to have a negative sign on it, right? That's my cue for an odd even. I don't see any negatives on my u's, so I don't want one of those. Try again. Is it the cofunction? So the cue for a cofunction would be inside my trig, I should have a pi over 2 minus x. That's my cue if I want to use a cofunction. I don't see any of those inside my trigs, right? Yeah. So I don't want a cofunction. This is good though. Like, I think it's important that you're hearing, like, what do I need to look at to know which ones to look for, right? What should I look for in the problem to tell me where I need to be looking for an identity? Reciprocal? So you might, sure. So what I'm going to be looking for is a way where can I find an identity that I can turn cotangent into something that has a sign in it? Or can I take sine and turn it into something with a cotangent in it? So I'm looking to do one or the other. So if I look at my identities, do we see a cotangent identity that has a sign in it?
What are the identities?
Mm-hmm.
Oh.
That starts with cotangent on the left and has a sign after the equal sign on the right.
Quotient?
Yeah, Q2, right? So Q2 has two possibilities. It says cotangent could equal cosine over sine, or cotangent could be cosecant over secant.
It'd be cosine over
Sine. Yeah, we want the first option because the other part of our problem has sine in it. And eventually we want to combine this stuff down until we get one thing. You're done now, Aiden. Yep. That's not the end of the problem, but you've done one step, which is what I'm looking for. Colby.
Is that a 6 or a U?
Those are U's. Ashton, you're next. So now we're here. We have cosine U over sine U times sine U over 1. So algebra or identity? What do you think we need to do here? Great. What can we do? That's great. So we're left with just cosine U. That's a single trig function with no fraction. That's our final answer. We're done. Good job. Okay. Let's look at 8 next. So we're just going to kind of go through following the same kind of pattern. I'm going to talk through if there's questions about like what to do or why to do things kind of as we go. But mostly I'm going to be looking for ideas from you guys because I think it's really important that you get to hear feedback happen in real time of people's ideas and like why it's a good idea or bad idea or why you can do it or can't do it. So our next problem is number 8. That's tan of pi over 2 minus x times cosecant x all over cosecant squared x. Jamie, you are my next random poll. Algebra or identity?
Would it be identity?
Okay, what identity would you like to use?
Would you do cofunction?
Great. So I assume Jamie saw this pi over 2 minus x in there and said, okay, I can do a cofunction. Which cofunction are we going to do?
Would you have to do one that has tangent in it, or would you have to do one that has CSC?
You want the piece that has tangent of pi over 2 minus x.
So would you do C3?
I would do C6. C6. Shh. That allows us to replace tangent of pi over 2 minus x with cotangent.
Wait, why would you not do C3?
Because C3 doesn't have a tangent of pi over 2 minus x in it.
Oh.
Do you see it?
Yeah.
Cool. And it's just that simple, right? All right. Let's see. Thank you, Jamie. Next up is going to be Sammy. Algebra or identity? Great. What can we do? Great. We can reduce a CSC from the top with one of the CSCs from the bottom. So far, so good? Okay. Good job. Next up, Jacob. Algebra or identity? Great. What identity do you want to use? Okay, let me give you a little hint here. So when I have a fraction and I'm going to use an identity like this, I'm probably going to use a reciprocal or a quotient identity here, which can make a fraction inside of a fraction, which I kind of hate. So what I'm going to do to think about this is I'm going to think about it as like the top of my fraction over 1 times 1 over the bottom of my fraction. I'm going to think about it, the problem that way. And now either I'm going to look for a cotangent identity that has a cosecant in it, or a 1 over cosecant identity that has a tangent in it. Colby, what's up?
How do you know algebra or identity?
Sometimes it'll be both. So if I look at this, there's just a fraction, right? Right here. That's just a fraction. Can I reduce it? No, because the numerator and denominator are different, right? So there's nothing algebraic I can do.
So I was the other one identity. Going before it.
This was algebra. We reduced.
Or yeah, algebra. Why was that? Because you canceled out that?
Yeah, we reduced. We did an algebraic thing as opposed to using an identity. You know what I mean? And you could have done an identity here. We're going to need to use an identity eventually, but like Sammy saw an algebraic thing and said, like, let's reduce. I see stuff to get rid of. I want to get this down to one thing. If I can cross something out, like, I'm not going to sleep on that. Let me cross it out, which is generally what you want to be doing. Jacob, any ideas here?
You do
So you could, but that unfortunately doesn't put cotangent in terms of cosecant. So I'd want to look for a different one. You can, it's just not going to be helpful. What else you got?
So it's gotta have like cotangent and secant.
You want cotangent, cosecant together in the same identity, yes. Because eventually want to combine this stuff together into one thing, right?
Yeah.
So I don't want to just change cotangent to something else that doesn't have cosecant in it, because it's still going to be at the same, I'll just be stuck doing something else then. You know what I mean?
Oh, would it be Q2?
Yeah, let's do Q2. Good job. So Q2 says cotangent is cosecant. Oops, these are x's. Over secant. All right. Good job, Jacob. And next is Drake. Algebra identity. Algebra. Great. What do you want to do? What can we do algebraically?
You can cross out the cosecant.
Yep. And what's that leave us with? 1 over secant. Yep. Okay. That's good. And not here. Maggie, what can I do from here? I have 1 over secant. Algebra identity. Yeah, great. What identity can we use? Yep. Because that takes 1 over secant and just turns it into cosine. We're down to 1 identity, no fraction. We are dunzos. Say thanks to Colby. Okay, next up is number 9. Okay. All right, we have 1 minus cosine squared x over sine x. Ava. Algebra or identity? Great. What identity do you want to use?
use an odd even for this or no?
Well, I don't have any negative x's, right?
Oh, it's not.
So I wouldn't use an odd even here. Yep. Let's do this. So if I go back to my identity sheet, you remember when I did the video for the asynchronous lesson? We talked about these Pythagoreans are rearrangeable. So like if I subtract like cosine squared from both sides of P1, I could rewrite P1 as that, right? Or if instead I had subtracted sine squared from the start of P1, I could rewrite P1 like this, right? You see what I'm doing?
Yeah.
Now, my suggestion for you guys is on the sheet that I gave you, you go and you write out the other versions of P1, P2, P3 by just like adding and subtracting stuff from both sides so that you have those extra versions sitting there. Is everybody okay with what I mean there? I think that's super helpful, especially as you're just getting used to using these things, to have those extra versions laying around so they're nice and handy. So keeping this in mind, Ava, if we go back and we look at number 8 now, what identity do you see?
So then if we can use P1.
Yeah, to turn 1 minus cosine squared into sine squared. Evan, what's up? Sure. Oh, he's absent. Lucy, you're up next. Algebra identity. Great. What can we do? Great. So we'll just reduce that fraction, leaving us with just sine x. That's a single trig, no fraction. We're done. Everybody okay there? Okay. Next up is number 10. All right, Aaron Delaney. You got tan x over cosecant squared x plus tan x over secant squared x. Algebra identity. What identity would you like to use?
Wait, where did the algebras cancel? No, it's identity. Sorry.
What identity would you like to use? Which one? So you're going to turn tangent into what? So.
Oh no, you would do secant.
Okay. So you're going to make fractions inside of fractions then? That's okay. We can do that. It's not wrong. Can I make a suggestion here before you do that, though? Okay. Let's think about this then as like numerator over 1 times 1 over the denominators. I usually want to separate my problem like this whenever I'm going to use an identity that turns me into like a fraction inside of a fraction. Okay, and you said we're going to turn tangent using Q1 into secant over cosecant, right? Okay, that's fine. We can do that. All right, Mira, algebra identity.
Oh,
Okay, great. What algebra thing can we do?
can cancel out the secant on top and the one on the bottom.
What are we going to do over here, though?
The top one.
Well, what is the problem saying that we're doing with that? What's going on between those two fractions? What operation? Add, subtract, multiply, divide.
The multiply
Great. How do you multiply two fractions?
would be like the cosecants cancel.
Nope.
No.
So if I ask you to multiply like 2/3 times, 3/5. Actually, let's make that like 1/5. How do you do that?
Just multiply across.
Yeah. So you get like 2 over 3 times 5, right?
Mm-hmm.
So what's going to happen here?
The secant
Mm-hmm.
over
Mm-hmm.
cosecant to the third power.
Great. Very good. Okay. Let's see who's next. Tia, you're next. Algebra identity. Okay, what algebra are you going to do here? So you think we can do this? You cannot. Why not? We've done this before. What's different about this? What? Not because of that. Because it's addition. If that was multiplication there, you could absolutely do what you suggested. Because it's addition, you cannot. Okay, what identity would you like to use?
I do the quotient.
Which quotient one? Because you don't have a tangent or a cotangent in this problem. You changing your mind? Yeah, I think this is an algebra step here. I don't think there's a good identity to use here to make life easier. So what algebra thing can we do? Do you want to hear your menu of algebra options?
Sure.
Okay. You can combine like terms. You can reduce fractions. You can factor. You can FOIL. You can make common denominators. That's the stuff that comes to mind right away.
What was the first thing you said?
Combine like terms. Huh?
Could you for
What's that?
could you call for us?
Well, I mean, like, this is part of, it's not trying to embarrass anybody. It just, this is, the point of this is to get us to, like, simulate what's going to happen when you have to do this on your own, and help you talk through, like, what are the options? How do I know if something's a good idea or bad idea? And this is all we're trying to do right here, right? We're just trying to, like, you have no intuition as how to do a problem like this. Because there's not one set rule of, like, this is the procedure, we just do the procedure every time. It's different than that. Like, it takes a little bit of, like, experience and a little bit of creativity to kind of see the easy ways to do these things. That's all I'm trying to do right now, is, like, have you, like, talk through what are the options, what are the things that I would try to do, and have me either shoot them down and be like, no, here's why you can't do that because you're breaking an algebra rule, or why it's maybe not a good idea that we do that, and explain to you what I'm seeing in the problem is to tell you, like, oh, okay, that's not a good idea to do in this case. But, like, I think this is important, letting us kind of, like, struggle through these things. You know what I'm saying? Like, it's not me trying to be hard. It's like me trying to give you, like, build some intuition. I don't know a better way to do this other than putting some training wheels on and letting me hold on to the back of the bicycle while you try to figure this out. Do you know what I mean? So that's all I'm trying to do here. It's not like me trying to be a jerk, although it's going to sound like me trying to be a jerk, but it's not. Like, I'm just trying to help in the best way I know how. So Tia, when I look at this, in general, when I look at this problem, what I see is two fractions, right? They're being added together. If I gave you, like, this problem and told you to do it, what would you need to do? Make a common denominator. Guess what we're going to do in this situation that's kind of like the same thing but yuckier? Make a common denominator. Is everybody okay with that idea? So what will the common denominator be between cosine cubed x and then cosine x times secant x? So the first fraction will multiply by secant x over secant x. That's fine. What are we going to multiply the second fraction by then? Well, what is this denominator right now? It's secant x times cosecant cubed, right? If I look at this denominator, I have I have the secant piece, right? But this one has secant cubed, this one has secant to the first. So how am I going to change that secant to the first to secant cubed? Yeah. Cosecant squared, yes. There you go. Thank you, Tia. All right. People that had your hands up, were you trying to help Tia, or did you have a suggestion or a question or something?
I have a question. Can you go back the other way?
Mhm.
Right there. Would you be able to combine the secant with the other secant and the cosecant all together and create a cosecant to the forward for the secant to the second?
You're talking here?
Yeah.
No, that's not how you add fractions, right? You have to have a common denominator, right? If I have like 2/3 plus like 1/2, I can't just somehow like combine numerators and denominators and stuff together. Like you have to make a common denominator to do that, right? Is that
Yeah.
okay? Mira, what's up? You had a hand too?
Oh, can I go to the bathroom?
Oh, sure. All right, so when I multiply this stuff out, secant times secant is secant squared. 1 times cosecant is just, or 1 times cosecant squared is cosecant squared. And the bottom is secant x times cosecant cubed x. Oh, he's in the bathroom. Colby.
Hey, please use the restroom.
Sure. All right, what do you got here for ideas?
Algebra.
Okay, what algebra thing do you want to do?
Cross out the secants.
So you want to do like that, right? Is that okay? So let's ask you this question. If I have this problem, that should be 4/6, right? If I do what you suggested, when I just get 1/2, are those two fractions the same? No, do you think you can do what you suggested? Not anymore, right? Okay. So what about this problem is different that doesn't allow me to do that cross off that we've done here a couple of times? Yes. Addition means you can't reduce, at least from one piece of the addition problem. You can either reduce the whole thing or nothing at all. Okay?
So is it not algebra?
I don't think there's an algebra thing to do here. Sure.
Is it?
Well, we don't have a tangent anywhere in the problem, right? That's what you kind of need as your starting piece for Q1. Won't be any cofunctions because we don't have a pi over 2 minus x anywhere. So this is tough, right? It's seeing what to do here. It feels like we're kind of stuck at a spot. This is the piece that I need to deal with. So I need to be able to add those two things together, right? As they're currently written, I cannot add them together. What I'm going to do, what we want to do is we want to use our reciprocal identities. We're going to use R4 and R5 so that we could write this as like to do this.
non-binding identity?
Well, now we are in a spot where I could add these two things together. But to add these things together, what do I need? What would that common denominator be? It'll be cosine squared times sine squared. Right? If I have like 1/2 plus 1/3, the common denominator is going to be like 2 times 3, right? So like this is like my 1/2, that's like my 1/3, so my common denominator is going to be like sine squared times cosine squared. Do you see that?
Yeah.
Okay. So in the interest of things not getting like ballooning out of control, I'm going to just write down the fraction now that we've added everything together. Nope, and in fact, you guys have taken a really inefficient way to get to the end of this one. We'll go back and show you like the way Mr. Kulik would have done it in like 3 steps. But that's okay. Part of building intuition and like recognizing the shortcuts is realizing like, oh boy, if I miss that shortcut, it's gonna be like a long trip to get, a roundabout trip to get to the end. All right. I'm going to talk through just the rest of this because this is getting pretty long here, right? All right. What do I see here? That is a Pythagorean. That's P1. Sine squared plus cosine squared is 1. And now I'm going to rewrite that numerator instead of 1 over sine squared times cosine squared. I'm going to write 1 over sine squared times 1 over cosine squared. And then I'll use R4 and R5 again to make that cosecant squared times secant squared. And we can do some canceling now. And that's just Q1, which is tangent. And that stinks, Mr. Kulik. I am mad about this problem. This took way too long. And I hate that you knew there was an easier, better way of me doing this, and you let us go down this terrible, stinky, long, convoluted path. Makes me angry. Okay, you ready to see the shortcut?
Yeah.
What Mr. Kulik would see? So I'm going to start by making common denominator. But here's the trick. What common denominator am I going to choose? Not secant. Not tangent. Not cotangent. Nope. One. That is the common denominator that I'm going to make. You hate this. I know, it's pretty angry. Well, here's the thing. I'll explain to you what I look at when I'm going to see to use this trick. But remember, you can make any common denominator you want, right? 1 is often going to be your best bet for common denominators for these trig things, because it just gets rid of the fraction altogether, and life is much nicer without a bunch of fractions rattling around. Do you like fractions? No. This is a really effective trick to getting rid of your fractions in a trig situation, okay? So what can I multiply cosecant by to eliminate the cosecant squared in the bottom there? What can I multiply the top and bottom of this by? Look at your identity sheet and look at R4. What is cosecant, or what is 1 over cosecant, what is cosecant equal to? 1 over sine. So if I multiply the top and bottom of this by sine squared, what's sine squared times 1 over sine squared going to give me? Just 1, right? So what should I multiply the top and bottom of tan x over secant squared by?
I have a question.
Okay.
I thought we made the common denominator 1. Where did we get all the other stuff?
You're going to see it in just a second. This is what I'm doing to get the common denominator of 1, okay?
Are we dividing by the opposites of what's the denominator?
Just give me a second. I'll re-explain. I just want to get through to showing you what this is. So what do I multiply the second one by?
1 over cosine?
Okay, so that's what secant is. So I want to multiply the top and bottom by cosine squared.
Why squared?
Because the bottom is squared. Because it's secant squared and cosecant squared. Okay. So remember, cosecant is 1 over cosecant squared is 1 over sine squared, right? Everybody's okay with that? Will?
Yeah.
When I multiply sine squared with 1 over sine squared, I get 1. Bingo! And then when I multiply 1 over cosine squared by cosine squared, I get 1. This is the better way of doing it. Jamie, sure. Shh. All right. So if I look at what I have now, I have sine squared x times tan x plus tan x times cosine squared x. Do you notice something in common? Tangent, right? I'm going to factor that out. Who recognizes sine squared plus cosine squared?
That's P1.
That's P1. What's it equal to?
1.
1. So I'm just left with tangent times 1 or tangent. Done. That was a lot nicer than the previous one, right?
Yeah.
Yes.
Just a little.
Just a little. So let's track back to the beginning and just illustrate to you now what I'm seeing to make a common denominator of 1. As long as my denominator involves no addition and subtraction, I can use this trick. You should all be listening carefully because this is like really helpful shortcuts we're kind of illustrating here. I just showed you how terrible this went of a problem if you tried to do it naively without realizing the shortcut that was present, versus how simple this became if we used the shortcut, right? This is a valuable shortcut. Whenever I have a fraction where the denominator doesn't have addition and subtraction in it, I can use this tool. Okay? Will I always use this tool straight away? No, but I would rather use this whenever it comes to making a common denominator. Right? If I look at a problem and go, I'm going to need to make a common denominator here, this is how I'm going to do it. Unless you have addition or subtraction in the denominator, in which case you're just in a lot of trouble. We'll look at some examples of when that happens here. Does that feel okay as to what I'm looking for? Or what I'm looking at to know to do this? Okay. These are good tricks, guys. They're not all as bad as 10. Sometimes it's very clear what to do and there's not like a bad choice that makes the problem like really like a black hole of steps. Most of the time that's not the case. All right. See you, Jacob. Let's see, who's next? Will Hannah, number 11. Algebra or identity? What are you thinking?
Algebra.
Okay, what are you planning on doing?
I think that we're gonna have to change the denominator. Simplify the top.
Okay, so let's hit these one at a time, right? If I look at this, it's all one fraction, right?
Mm-hmm.
Probably not going to mess with the denominator until I absolutely have to, because it's already a single fraction. I have a common denominator. I don't need to do that. So I'm going to leave the denominator probably how it is. Okay? What'd you say is your second guess?
I said that we had to simplify the top.
Okay? If I look at the top, I have just three things that are being added together, right?
Yeah.
Are any of them the same?
No.
Can any of them add together then?
No.
Okay. So probably can't do that.
An identity.
So let's look for an identity. What I notice is when I look at the numerator, I have things squared and I have addition. When I see those two things together, what am I thinking? What type of identity has things squared in it and addition?
Pythagorean.
The Pythagorean. Is there a Pythagorean identity that I might use in this case, Will?
Maybe we could use, I guess, we could use all three of them. Because sine, cosine, maybe.
I don't know how you could use P2.
Isn't, oh, no, wait, no. Cotation's not that.
And I don't think I'd use P3.
You can use P1.
Yeah. What is P1 going to allow me to do?
P1's going to allow you to
Sine squared plus cosine squared is
so
just 1.
1 plus tangent squared.
Mm-hmm.
All right, that makes sense.
Does that feel okay?
Yeah.
Now, Mr. Kulik, the sine squared and cosine squared weren't right next to each other. How did you use P1 still?
It's addition.
Because it's addition. I have three things added together. 1 plus 2 plus 3 is the same as 1 plus 3 plus 2, right? The order doesn't matter if I'm adding. That's all. Everybody feel good?
Yeah.
Good.
So is that our final answer? Or just
It's going to go, we need to get it down to one trig function. Jack Holman, you're next. All right. What do you got to do now? Identity or algebra?
Is that identity?
Good. Which identity can we use?
We use tan.
Well, if I look at the top, I see a 1, a plus, and something squared. What identities have all those things in it?
Wait. Say again?
So I have 1 plus tangent squared at the top, right? I have a 1, an addition symbol, and a squared identity. Pythagoreans
Okay.
have all of those things. When I see ones, addition or subtraction, and then identity squared, think in Pythagoreans. Look at the Pythagoreans, see if you see the one that we need.
Is it P1?
It's not P1.
Is it P2?
It is not P2.
P3?
If I look at the top, 1 plus tangent squared, what does that say it's equal to?
1 over cotangent.
Are you looking at P3?
Wait, which one?
Three
I'm just so-
Pythagorean identities right here.
It's weird.
Yeah.
Secant squared.
So I'm going to trade out the numerator for secant squared.
So cancel out.
And Bella, what do we do?
The bottom row is 1 plus squared, so
Great. That one felt better, right? They're not all like terrible hard.
I have a question.
Yes, sir.
So for all of these, can we do that same thing where we're just finding formulas, simplifying it, or
That's basically all we're doing on all these problems.
all of them?
Yep.
Okay. Because on the last few I was confused, but on this one it's
Good. That's ideally that's what should be happening as we go through these longer. You're building up some intuition, and things become clearer and clearer as we go. Is the hope. These are getting, each time we go, should be a little bit easier to see what to do next or to follow along. Jack Kilpatrick, you're up first. Identity or algebra?
Identity.
Great, which identity?
Maybe OE2.
Yes, and if you're going to do OE2, you might as well also do OE.
5.
Great. So OE2 allows you to write, or OE5 allows you to write secant negative x, it's just secant x.
Yeah.
And OE2 allows you to write cosine negative x, it's just cosine x.
Yeah.
As soon as we saw the negative signs inside of our trig function like that, odd evens is where we live. Everybody cool? Good job. Next up is, we had to reload. And then that part of the program is broken, apparently. Colby, you're next. What are we doing? Algebra identity. Secant x times cosine x. Great. Which identity? Great. R5 allows us to rewrite secant as 1 over cosine. So we could think about it that way. And next, Mira, what happens?
cosine's cancel out.
Great. And what are we left with?
1.
1. Thanks, Mira. It's okay. That's okay.
For me.
Yeah. You'll have to answer hers for her next time.
I don't know.
13. Sine alpha minus tan alpha times cosine alpha plus cosine pi over 2 minus alpha. Luce, you're up first. Oh, dang it. Sammy, you're up next. He left. Ashton, you're up next.
Yeah.
What do you want to do? Algebra identity.
Identity.
Great. Which identity you want to use?
Is it,
Okay. There's two good ones that you could use here. The first one that I think we probably notice is I see this.
Could we do C1?
We would use one of the C's, but not C1 because we don't have. Oh, yes, I'm sorry. That is, yes, sorry. My apologies. Yes, that's exactly right. C1. I was looking at the wrong spot. Great. Good job.
What's the other one we could use?
Well, Bella, can you tell us the other identity? I said to you there's another one we could use here. Q1 is correct. Q1 allow us to rewrite the tangent as sine over cosine. Very good. And Jack Kilpatrick.
Got one.
It reloaded. Algebra identity.
Identity. Algebra.
Let's do algebra.
Algebra.
There's two good algebraic things to do here.
The cosines you cancel.
Great. That'll do. So we're left then with sine alpha minus sine alpha plus sine alpha. What can I do with that?
You can like cancel through the sine alphas.
Yep. So we're left with just,
Sine alpha.
you got it. Way to take us to the finish line. Right? Some of them are hard, some of them are easy. That one wasn't too bad. All right. Last one here. All right. We have 1 over 1 minus sine y plus 1 over 1 plus sine y. Jamie. Algebra identity.
Don't you have to make a common denominator?
Great idea. What would the common denominator be here?
Wouldn't you have to like multiply them by each other?
Yes. Perfect. So Jamie says the common denominator would be sine or 1 plus sine y times 1 minus sine y. All right, Jamie, can I ask you one follow-up question here as long as we're at it? You've done a great job so far. Why didn't you try to make a common denominator of 1 here? Because there's addition or subtraction in the denominators. Can't do that. Can't make a common denominator of 1 if you have addition and subtraction. Yep. Everybody okay? Oh my goodness. Come on, dummy. Those ones. There we go. All right. So let's multiply this out and write it as a fraction, yeah? So I have 1 plus sine y times 1, and then 1 times 1 minus sine y. Ava, what can I do next? Algebra identity. You can do algebra.
But we can't cancel them out because of that.
Correct. Well, I'll give you a hint. There's one algebra thing to do in the numerator, and then a different algebra thing to do in the denominator.
So we just add them together.
Great. What do you get when you add them all together? Close. You get 2. 1 plus 1 is 2. Sine y minus sine y is 0. Did you know, Mira, or did you just like say a number?
I just said 2.
Oh. Well, it was really a good guess.
Thank you.
Okay. How about the denominator? What can I do in there?
2.
Great. How do you multiply two things that are in parentheses? FOIL! Yeah, very good. So 1 times 1 is 1. 1 times negative sine y is negative sine y. Sine y times 1 is sine y. And sine y times negative sine y is negative sine y squared. Is that okay? When you combine like terms, what do we get? Right? Those guys had to give a 0. Okay. Will Hannah, you're next. So we got 2 over 1 minus sine squared y. Algebra or identity?
Could be identity.
Great. Which identity?
I'm thinking it's gonna be R4.
Nope.
Cosine and then sine squared over fraction.
When you see squared, what should you be thinking?
Pythagoras.
Yup.
P1.
Yes. What does 1 minus sine squared turn into?
1. Wait.
1 minus sine squared turns into?
Wait, for P1 it says that sine squared plus cosine squared is equal to 1. We don't have the
Yeah.
cosine squared.
Remember, if I subtract sine squared from both sides or subtract cosine squared from both sides, I can make like alternate versions of this. Right? We took a moment and kind of illustrated that earlier and asked you guys to write those down on your sheet.
Oh.
Maybe you want to do that. Just pointing that out there. Shh. All right. Next up, Aaron Delaney.
What would be
Yes, good.
yeah, I
Can I give you a hint? Let's think about it this way. Yes. So 1 over cosine squared is just secant squared. And you're done, Zos. What did you guys, how did this go today? Did we get better at it as it went?
Yeah, sure.
Did that help?
Yeah.
Going through and like getting all the bad ideas out and like seeing all the things like, ooh, that's an algebra mistake I would make. I'm glad that we, I know I can't reduce with addition now anymore. Like we made that mistake a couple of times and really hammered that. So your homework today is 7 through 14. So we're done, right? Because what did we just do? 7 through 14.
We just did that?
Yeah,
Oh, so you don't have any homework?
for now. Is that okay?
Yeah.
Okay. If you didn't finish your delta math, do you still need to do that?
Yes.
Will this be, will what we did right here be part of Sunday's problem set?
Yeah.
Yes. So if you took good notes and you're like, I'm done, good on you. Next time in class, we'll do some more practice on this with less of my support. Gonna kind of slowly pull this away. Is that okay? So I gave you the delta math first thing that was pretty straightforward. There's like no real algebra tricks to it, right? It's just like use the identity and reduce, basically. Here we started seeing algebra tricks mixed in with identities. I gave you support while doing this one. The next one I'm going to ask you guys to do kind of on your own with little support from me. You can ask questions and stuff, but I'm not going to like walk through it together. Colby, what's up? I would give you the identities. You don't need to memorize them.